Hello beautiful XR developer, and welcome to the third part of this tutorial series where we are building a mixed reality game for the meta quest inside Unity. Now, after making and spawning the ghosts in the previous episode, in this video we are going to learn how we can use a Navmesh in mixed reality to move our ghost to the player's position. But in the next episode we will do our core gameplay by spawning some orbs in the scene that the ghost will want to eat, and that we can protect by shooting the ghost with our ray. So make sure to subscribe and like this video. Now, as always, the source code is available on my Patreon if you'd like to support my work and even get access to exclusive content. And of course, this entire series is sponsored by Cognitive 3D, so this is your weekly reminder to go and try the tool for yourself. It is amazing, and if you don't know already, Cognitive 3D is a free tool that allows you to collect data in your game to better understand how it is being played. With Cognitive 3D, you can watch replay of your player, get comprehensive data about their session, know if your game meets your objective, and so much more. So don't wait any longer and go register for free with the link you will find in the description down below. But without further ado, let's get started with our tutorial. Okay guys, so we are back where we were left at the end of last episode. So right now, if I click on play, this is what's going on. We have ghosts spawning, but they are staying still. And so what we want is have the ghost move and chase after something. And this is what I'm going to show you using a Navmesh. So as you probably already know, a Navmesh is an artificial intelligence feature by Unity, which will do some pathfinding to move something to a target destination. Now, typically, if you wanted to add Navmesh inside your project, you should first go to Windows, Package Manager, and you should install here the AI navigation package that should already be there in your project if you've downloaded the Meta XR All-in-One SDK. So now let's close this Windows. And the next step to create a Navmesh is first to right-click, create empty. We can call this one Navmesh Surface. We can recenter the position to 000 and add as a component a Navmesh surface. Beautiful. So this is the component right there. But as you can see, it doesn't contain any data. So the Navmesh data, so the walkable area for the agent. So to create a Navmesh data, what you can do is right click, 3D object. Let's create, for example, a plane like so. We can even scaling up a little bit. And there, if I go back to the Navmesh surface, there we have some settings to collect all of the objects that we want to use as Navmesh. For example, for the use geometry, we can instead select it to physics colliders. And for the object collection, as you can see, all the game objects will be gathered, which is not good. So instead, I'm going to select the plane and add as a component a Navmesh modifier. Beautiful. And there on the Navmesh modifier, what you can do is override the area to say if you can actually walk on this surface or that you cannot walk on it. So let's leave it like this. Go back to the Navmesh surface. And for the collect object, let's set it to Navmesh modifier component only so that it will take count only of the plane that has this component. Now, anyway, if we click on baked, this is what you should see. As you can see, a Navmesh surface has been currently set for our game, which is the blue area, which took as a data the plane mesh collider over there that has the Navmesh modifier. Now, if we wanted to go a bit further than this, for example, create some obstacle, we could right click, 3D object, cube, there you go, and we can change the size of this cube. And on this cube, we can do the same, which is add a Navmesh modifier. And this time, if we wanted to have this cube be an obstacle, we could set the override area to not walkable. Now, if we go back to the Navmesh surface, click on bake, this is what you should see. As you can see, the Navmesh surface is avoiding now our cube. And so this is the traditional way that you can create some Navmesh surface that will be used by the Navmesh to move around. Okay, so this is for pre-baked Navmesh, but how do we create Navmesh at runtime? Because our scene model is being created at runtime itself. And then the second question is, how do you add a Navmesh modifier and a collider to a scene model element? Now, I'm going to show you this in a minute, but first I want to show you how we can use already this Navmesh surface to make the ghost move. Oh, and by the way, I've noticed here that for the plane, the position is not set to 0, 0, 0 on all axes. Same goes for the y-axis of the cube. Perfect. So let me get back my Navmesh surface and rebake. There you go. This is because I really want here this plane to be at the floor position. Now anyway, let's move our ghost using this surface. If we go to our ghost spawner, we can see that the prefab that we are spawning for the ghost is this one. So let's select it over there, beautiful. So this is the ghost prefab that we are using. We can double click on it to go into prefab mode. And so what I'm going to do is add two things. First, a ghost component. There we go, that we can create as a new script. And then we are going to add a Navmesh agent. So as you can see, the Navmesh agent is like a collider. And the Navmesh agent component goal is to move here this little ghost using the Navmesh surface. Now, as you can see, the shape is not good, it seems. If you go down below, there is some obstacle avoidance settings that you can do. So what I'm going to do is actually reduce a little bit the radius, like so. I'm going to reduce also the height to something like this. 1 meter seems good enough. And actually you can see that my little ghost with its little eyes are set on the floor position. So what I'm going to do is actually select these two, press on W to have the move key. If we go here at the top, we can set the pivot to be global, and we can increase a little bit the ghost so that if we select the parent, this is what you should see. We can even maybe increase it a little bit higher. There you go. So this seems a bit nicer like this. This way we will have the ghost parent, which will be at the base. And as you can see with this configuration, the radius and the height seem as good to avoid the obstacle. Now, by the way, you can see that the agent type is set to humanoid. Actually, if you click on open agent settings, you can see that there is a bunch of components to set for the movement of the agent. For example, the step height, the max slope, and stuff like this, which you can edit over there. Now, by the way, if we close these windows and go back to the prefab here, let's double click on the Go script so that we will be able to edit it. So the Go script will be very simple. So at the top, we can write using Unity engine.ai. This will allow us to get the Navmesh agent. So if we write public Navmesh agent, beautiful, we can get the components. I'm also going to add a public float for the speed that we can set initially to 1. And there you go. Now on the update function, what we can do is actually get a target position. Now this is something that we will change afterwards in the next episode, because we want the ghost to target one of the orb that we will spawn in our scene. But just to debug right now, what I'm going to do is set the target position to be camera.main.transform.position. So here, as the name suggests, the camera.main.transform.position will give you the position of the main camera. And if you don't know, let me click here. And the main camera is actually the camera that has here this little tag right there. So basically, this will make sure that the target position is your head, in other words. So let's set the destination of the agent using agent.setDestination and use here the target position. We can also set the agent.speed to be the speed that we have as a parameter. And now everything should be good already. With this, we are able to set the destination of the agent, which should avoid the obstacle and use the Navmesh surface. So let's save and go back to Unity. Okay, here you go. So don't forget to drag here the Navmesh agent to the agent over there. And now one thing to do, and it is to click on play to find out if the ghost will be able to move here using the Navmesh surface, but also to set its destination to the players. And there you go, guys. As you can see, it is working. The ghosts are spawning and they are moving to the player's eyes, which is right there. So it means that everything is working and that we are now able to make the ghost move. But of course, right now, the big issue is that, well, the Navmesh surface that we are using right there is not following the player's real environment. So let me answer two big questions. First, how do we create a Navmesh at runtime? And then how do we use it for our scene model? So let me show you. Okay, so basically the thing that we want to do is add a Navmesh modifier right there to some element of the scene model. Now anyway, let me select here our little cube and delete it because we don't need it. I'm going to actually keep here the plane because I will need it. But anyway, if we go to the Navmesh surface, I'm going to click on add component and add an anchor prefab spawner. Now, as the name suggests, the anchor prefab spawner will spawn a prefab for a certain type of anchor. Now, as you can see, this is way more precise than what's possible with the effect mesh. Now, the effect mesh will spawn a cube or a quad for each anchor of the player scene model and will assign to the mesh here this material right there. But the big difference with here the anchor prefab spawner is that if I click on the plus button, I can say which prefab I want to spawn for a specific label. So for example, if I right click, go to create empty, I'm going to call this one obstacle box. Beautiful. We can then right click, go to 3D object and then to cube. Beautiful. And now I'm going to click on add component and add a Navmesh modifier. Beautiful. Now, as you probably guessed it, we are going to use this as an obstacle. So on the override area, I'm going to set it to not walkable. Now here, make sure that the obstacle box position is at 0, 0, 0. Beautiful. And we are going to drag this obstacle box in our project folder to turn it into a prefab. Now we can select the one in our scene, remove it with the delete button, go to Navmesh surface. And so here for the prefab, I'm going to click on the plus button and drag here the obstacle box that we just created. And now what's left is to simply set the label that we want to use to spawn this box. So in my case, I'm going to spawn one for the table, the couch. We can do one also for other storage, bed, screen, lamp, plant. Beautiful. So everything that's basically an obstacle. Now let me save. And let's find out how this works if I click on play. And there you go. This is what you should see. As you can see, this is my room with all of my table. This is my computer desk and this is a storage box. And if I click on it, you can see that for here, this anchor from the scene model with the anchor prefab spawner, we have actually spawned an obstacle box that has been updated with the appropriate scale and position. And as you can see here, our Navmesh modifier is over there. This answers one of the two questions. With this, we are able to add Navmesh modifier to a certain element of the scene model. Now, if you wanted, for example, to not create an obstacle box, but to create a walkable box, you could just duplicate the prefab over there and set the Navmesh modifier to walkable. And I'm going to show you this as an exercise at the end of this tutorial. Now let me answer to you the second question, which is how do we bake a Navmesh at runtime? So for this, let's first clear the Navmesh data that we have here by clicking over there. And I'm going to click on add component and add a runtime Navmesh builder component. There we go. If we double click on the script to open it, you will see this script is very easy as well. We can simply write using unityengine.ai. Then we need another namespace, this time using a unity.ai.navigation. Beautiful. And now at the top, what we need is a reference to the private Navmesh surface that we have, that we can call Navmesh surface. So I can set this component at the start by going get component Navmesh surface. And then to build a Navmesh surface, it is very simple. We can simply do Navmesh surface dot build Navmesh. As simple as this. But there is a big issue if we do this right there, is that of course the scene model has not launched sometimes. So what we need is actually to wait for the scene model to be initialized by doing mruk. Oh, and let me write using meta.xr.mrUtilityKit at the top, and let's do mruk.instance.register scene loaded callback. And what we can do is add a public void function called build Navmesh. There you go. We can copy this function over there and simply do on this function the Navmesh surface dot build Navmesh call. And there you go. This way we will still wait for the scene loading to occur. And after it has been loaded, we will build our Navmesh so that everything will be nice. So let's save, go back to Unity. And now let's find out if we are able to build the Navmesh at runtime from the script. So let's click on play. And there you go, these things are turned blue, which means that we have been able to build a Navmesh. And as you can see, we can even see the Navmesh data over there, which has been built, but there is an issue. And the issue is that if we click on one of the cube, we can see that the cube has a Navmesh modifier, but the Navmesh modifier has not been taken into account. And if I leave play mode, this is just simply because there is a little issue in the order of script over there. So it's because the runtime Navmesh builder is being called before the Anchor prefab spawner, which is a big problem. But we have a solution to make sure that it is not the case. If we double click on the runtime Navmesh builder, what I'm going to do is instead of void, write IEnumerator, beautiful, and right here for the build Navmesh, rename it to build Navmesh routine. And what we can do is write yield return new wait for end of frame, beautiful. And if instead we write a public void build Navmesh function that will call the start coroutine build Navmesh routine. So by doing this, we are actually, instead of directly building the Navmesh, we are actually calling a coroutine, which will first wait for the end of the frame, and then at the end of the frame, we will build our beautiful Navmesh. And this way we'll make sure that first the anchor are spawning before we build our Navmesh. And there you go, if we click on play, as you can see, it is working. We have a beautiful Navmesh surface. And as you can see, all of the little furnitures of the room are being taken into account. And you can see that the ghosts are avoiding them, which is awesome. Now, there are some improvements that we can do, of course. The first one is that here you can see that for the plane, I don't want the mesh renderer to show, so I'm going to disable it. There you go. Same goes for the obstacles. So let me go to Navmesh surface, click on the obstacle box. What we can do is simply disable the mesh renderer, beautiful, and go back to Unity. Now, if I click on play, there you go. As you can see, the Navmesh surface is updated, but there is no more cube model, which is what we want, of course, the real one in our real world. But maybe also another improvement is that maybe the area around here, each obstacle is a bit too big. So what you can actually do is leave play mode. And here on the agent type, we can go to open agent settings and maybe reduce the radius to 0.1. There you go. So that if we leave and that we click on play, there you go. As you can see, the contour is a bit smaller, which leaves some places for the ghost to pass between two furnitures, for example. And there you go, this sums up, or you can create an awesome Navmesh surface that works at runtime for our scene model. As you can see, this works really great. And by the way, as promised, I want to show you that instead of an obstacle box that we have here, we can, for example, create a walkable box by simply select it and pressing on Ctrl D. I'm going to rename it walkable box, beautiful. We can double click on it, select the cube, and here we can set the area type to walkable. And then if we go back to the Navmesh surface, here you can actually replace the obstacle box by the walkable box, or customize here all of the prefab to spawn with different labels that you want. But there is something more to tell you here, because of course the obstacle box works great for a plant, a storage, but it doesn't work for the floor or the ceiling, which are flat area. So what you can actually do, let me show you. If I select the walkable box, I can duplicate it, and instead I'm going to call it walkable quad. And then if I double click on it, I can simply select the cube here and set the Z value to 0.001. And as you can see, this flattens out everything, so that's perfect. So let's go back, select our Navmesh surface, and just as an example, if I click on the plus button, I can drag here the walkable quad instead of the obstacle box. And for the labels, I'm going to set everything to nothing and then just set it to floor. And now if I click on play, there you go. As you can see, for our floor, this has added here the walkable quad, which has taken the good size for our room. So this means that in the case that you don't want the ghost to walk on all of this surface, you can actually simply disable it. And because we've added here a walkable quad for the floor, this will make the surface of the Navmesh take into account the floor of the players. So let me click on play. And there you go. As you can see that in this example, because we've removed here the plane that was a bit bigger, we have now created a Navmesh surface area with just the floor of the player that avoids all of the different furniture that we have. Okay, so let's leave play mode, and this was just a little example for you. Now in my case, I'm going to remove this one, the floor, and re-enable the plane because I still want the ghost to walk behind the wall of the player and enters the room through the wall. And there you go, this concludes our tutorial. At this point, you can simply build and run, and this is what you should see. And there you go guys, this is already so much fun. We can play hide and seek with the little ghost that we made. Now I hope that you enjoy watching this tutorial and that you are ready for the next one. Big shout out to the new Patreon, which will appear soon on the screen. If like them, you want to get access to the source code of this game and other exclusive content, join us, link in the description. A big shout out to Cognitive 3D, the sponsor of this series. And if you'd like to know more about your game and better understand your player, you can try the tool for free by registering with the link you will find in the description. Thank you for watching and see you soon. Bye bye.